Okay, welcome to today's Excliner. We are taking a serious cosmic zoom-in journey today into Caldwell 65. You might know it as the Sculptor galaxy. We're going to travel all the way from the grand, sweeping scale of its massive stellar outflows, right down to the fundamental, invisible electromagnetic forces that actually hold the whole thing together. It's an absolutely fascinating system. It basically acts like a giant celestial laboratory for us, letting us see how intense star formation, molecular gas, and the underlying laws of physics all interact on a massive galactic scale.
Here is our flight plan for today. We'll start with a quick welcome to Caldwell 65 to get our bearings, then dive into the mechanics of its Starburst engine. From there, we'll check out its unique cosmic beacons, uncover the surprising role of electricity and magnetism, and finally bring it all together into one unified galactic picture. Let's get going.
Section 1. Welcome to Caldwell 65, a distant neighbor. Let's get ourselves oriented with our cosmic target. So, discovered way back in 1783 by the pioneering astronomer Caroline Herschel, Caldwell 65 is this stunning cosmic structure located within the Sculptor constellation. It's officially classified as a weakly barred spiral galaxy, which basically means it has a central bar-shaped structure made of stars, but, it just isn't quite as pronounced as what you'd see in a strongly barred galaxy. But what Caldwell 65 is truly famous for is its intense nuclear starburst activity. It is literally churning out stars at a rate several times higher than our own Milky Way, with the vast majority of that explosive birth happening right in its central core. To put that true scale into perspective, this galaxy sits a staggering 11.4 million light-years away from us. That is a massive distance, meaning observing the delicate internal mechanics of its core requires immense precision. But we're actually pretty lucky, because we view it at a highly inclined, nearly edge-on angle of about 78 degrees. That gives us this incredible cross-sectional view of the gas flows and outflows being driven by its hyperactive center. Moving right along to Section 2, the Starburst engine. This is where things get really wild. To understand how this galaxy produces so many stars, you kind of have to look at it as this incredibly dynamic, almost paradoxical four-step engine. First up, think of the galaxy's stellar bar as a massive funnel. Its gravitational pull efficiently channels vast amounts of cold molecular gas directly into the central molecular zone. Second, as this gas flows inward, it collides, creating low-velocity shocks. Third, this dense, shocked gas rapidly collapses to ignite superstar clusters, which, by the way, hold the vast majority of the starburst's star formation. And finally, the immense energy and radiation from these newborn clusters blast out a multi-phase wind, famously known as the Southwest Streamer. What's brilliant here is that this massive outflow actually regulates the star formation. It's literally blowing its own fuel right out of the galactic center. And when we look closer at these superstar clusters using high-resolution arrays, they aren't just forming randomly. No way. They are packed into this incredibly dense linear structure, spanning just 155 parsecs across. In 3 dimensions, the architecture here is geometrically beautiful. The gas and clusters follow what astrophysicists call X2 orbits. Basically, these are specific orbital paths that lie perfectly perpendicular to the main galactic bar. So the bar feeds the gas in, and the X2 orbits elegantly capture it, creating a perfectly concentrated ring of extreme star formation. All right, Section 3, cosmic beacons or unique masers. All of this intense, turbulent activity creates the perfect environment for some truly unique cosmic signals. Now, before we get into the specific signals, let's quickly define what we're even talking about here. What is a maser? It stands for microwave amplification by stimulated emission of radiation. The easiest way to think about it is as a naturally occurring cosmic microwave laser. Just like a laser amplifies visible light into a tight, intense beam, a maser does the exact same thing, but with microwave frequencies. In astrophysics, these masers act as brilliant beacons that broadcast from very specific environments, usually regions filled with cool molecular gas experiencing those exact low-velocity shocks we just talked about. And because of its extreme environment, Caldwell 65 hosts an absolute treasure trove of these beacons, including some groundbreaking astronomical firsts. For example, it was the site of the very first extragalactic detection of Class 1 methanol masers, operating at 36 and 44 gigahertz. The 36 gigahertz maser here is a total monster. It broadcasts 10,000 to 100,000 times stronger than anything we see in typical star formation regions in our own Milky Way. It also hosts water masers and hydroxyl masers, but maybe most astonishingly, researchers recently made the unprecedented detection of a cyanoacetylene maser. This is huge, the very first detection of this specific maser transition in any source ever. And mapping this out brilliantly illustrates exactly where these powerful 36 gigahertz methanol masers are localized. Notice how the emission isn't just scattered everywhere randomly. It is highly concentrated right at that critical interface where the galaxy's funneling stellar bar collides with the central molecular zone. The masers are tracing the exact boundary where the cool inflowing gas slams into the core, creating those low-velocity shocks that trigger the massive starbursts. It is a perfect, undeniable visual confirmation of the galaxy's internal engine hard at work. Which brings us to Section 4, Electricity and Cosmic Magnetism. What invisible physical forces are actually holding this highly charged plasma galaxy together? See, when we talk about massive galactic structures and gas flows, astrophysics usually relies heavily on magnetic fields to explain how these plasmas are shaped. But according to researchers like Donald E. Scott, who draws strictly on fundamental Maxwell equations, we are missing a massive piece of the puzzle here. We simply cannot properly explain the magnetic fields shaping these galaxies without explicitly acknowledging the electric currents that cause them. It's a real paradigm-shifting idea. A magnetic field doesn't just exist on its own. It requires an electric current, a flow of charge, to generate it. Ignoring the electric current is basically ignoring the root cause of the magnetic phenomena we're observing. When we look at simple circuit dynamics, we can establish a direct cause and effect relationship based on those Maxwell equations. It's honestly fascinating to think that the exact same simple circuit dynamics we experience here on Earth scale all the way up to govern entire galaxies. When you have an input electric current flowing through a loop, it generates a corresponding magnetic field. If that input current gets stronger, the magnetic field gets stronger at an equal rate. The critical takeaway? Magnetic fields don't possess self-initiated volition. They don't just move around on their own. They are the direct, measurable result of underlying electric currents flowing through the conductive plasma of space. Now, let's see how this builds into something even more dynamic. When that primary current varies in strength over time, getting stronger then weaker, but never actually changing its direction, it creates a fluctuating magnetic field. According to Faraday's law, this fluctuating field utilizes what's known as transformer action to induce secondary currents in nearby conductive paths. Think of it like nature's own giant wireless charger, transmitting power without any physical contact. As the primary field strengthens and weakens, this secondary current actually reverses its direction to oppose the change. This is a brilliantly simple, entirely electrically driven mechanism that explains how massive cosmic magnetic fields can cyclically reverse their polarities without the main driving current ever needing to change direction. Let's move to Section 5, our final section, a unified galactic picture. Let's step back and look at how all these pieces fit together. What we have here is a deeply interconnected system, from the sweeping stellar bar acting as a galactic funnel to the explosive superstar clusters on their beautiful geometric orbits, all the way down to the quantum-level maser emissions broadcasting from shock boundaries. All of this plasma and gas is navigating a complex magnetic architecture. And as we've just seen, it's the underlying invisible electric currents flowing through the cosmic plasma that generate and dictate those fields. The currents shape the fields guide the gas fuels the starburst, and the starburst powers the massive winds. It is a stunningly complex electrical and gravitational ecosystem operating 11.4 million light-years away. Which leaves us with a really fascinating final thought to ponder. We can look deep into the heart of the Sculptor galaxy and trace how fundamental, universally applicable electrical forces and magnetic circuits drive its massive engine. So, if that is true for a galaxy 11.4 million light-years away, how much of the rest of our visible universe, from the smallest star-forming regions to the vastest galaxy clusters, is being secretly shaped and architected by these exact same invisible cosmic currents? It kind of changes how you look up at the night sky, doesn't it? Thanks for joining me on this explainer, and keep looking up.